Next speaker is Aga Karakuzu from the Neurolibre Lab in Montreal. He's involved in many open science projects, and he's also leading the development of Neurolibre, which he's going to talk about now. Thank you.
Yes, you can see the screen now and hear me.
Yep.
Good. Okay, perfect. So thank you so much for the introduction. Before I start, I really like to take a moment and appreciate this illustration. And I guess in the context of this previous presentation, it's going to make really good sense. On the left, we see some zombies and mummies throwing some money to pull down the PDF paywalls. But as these are zombie code and data, they are not actually thriving. To revive them, we need to position ourselves on the right side of the things, which definitely requires taking advantage of the recent technology and developments to do better than a PDF. But again, I guess I need to unpack this unusual title, which makes me suspicious that why this was the last presentation in the whole conference. What it means to have PDFs haunted by zombie code and mummified data, and what it actually means to revive them. Zombie code is a common expression used to describe sections, a software project that are no longer executed or they have become obsolete. But in other terms, it refers to the code that is neither dead nor alive. It is undead. So when we think about code repositories mentioned in an article, which is a PDF, they are like zombies because it is not easy for readers to run them in relevance with the context of the article. And mummified data is the data that you can find, but you need to unwrap them in many different ways to see what's underneath. Again, unless there is a really good documentation that is aware of both of the article context and also the code that uses that data is going to be undead as well. But why do they haunt PDFs? Well, PDFs are static documents and they make a great residence to host zombie code and mummified data. And when you get close, you hear some eerie whispers like from the zombie code. It says, you cannot run the zombie code, but you can run away from it. Absent the environment to host, dependencies are miss and hit. And then you approach to mummified data and you hear, mummified data is persona non grata. What does it add its own? Nada. Unwrapping its relevance is not fun. Where do you use it to make it run? So we always have this confusion whenever we find some of the code and data availability statements and then go try to piece it all together and get into the head of the person who write that code and share the data to regenerate the figures. It's a big challenge. So if you were born in early 90s, like I am, you'll probably recognize these modified lyrics. I'm not going to go over them, but here, the red book in this illustration is our editorial bot, Robonero, who works for Neurolibre. And here it's unwrapping the bandages of data before putting it in Neurolibre Cloud to revive it together with code in the context of an article. So, Neurolibre reproducible preprints are not haunted, but a powerhouse for code, data, runtime, and scientific narrative. They are published as discoverable and citable preprints, which are open books that you can execute online. You can scan this beautiful QR code to take a look at the examples. So far, we managed to publish 8 reproducible preprints for which there is more than 10 gigabytes of data cached on our servers. Each preprint comes with its own Docker image, and Neurolibre is committed to keep them functional. We are keeping them in our private Docker registry so that they don't get deleted. In case you like to rebuild the runtime environment, you won't run into the problem of transition, the problem of obsolete dependencies. And then all the reproducibility assets creating the preprint are archived and DOI linked to the publication. As they are preprints, they do not prevent you from publishing it in peer-reviewed journals. If anything, to our experience so far, they make the process more appealing both to the reviewers and to the authors of these publications. And some of these preprints have already been published in eLife. There are some under review in magnetic resonance in medicine, aperture neuro, imaging neuroscience, and we also published some articles with PLOS computational biology. So I'll show you an example of reproducible preprint, which started as a blog post by Matthew Boudreau on QMR Labs blog to explain a variety of T1 mapping methods. Then it became a preprint on Neurolibre. Then Elsevier incorporated it in the quantitative MRI book, which is you can buy about $150 or something more, I don't know. But this content that went from Neurolibre to that book is published under CC BY license. So whatever you're going to see in the book is going to be exactly this, of course, missing all the cool features, such as the repository, dataset, a Jupyter book, a container. This is the snapshot of the page where DOIs are resolving into. At the center, you see a PDF, which was built from a collection of Jupyter notebooks and markdown files. And as you can see, it can include equations, citations, nicely formatted annotations, and more things. But the role of these PDFs are just to register content and to link to the archived reproducibility assets, which are on Zenodo, and each one of them are also DOI registered. And it also links to the technical screening records. So it's just for record keeping. It's just for the purpose of library. And this is the exciting version of the PDF. There are too many links. If you go and check the PDF, like visit for interactive reading of this article, visit the reproducible preprint, and then you see this page. It's a Jupyter book. In this case, on the left, there is a menu that helps you navigate the content. There are figures, citations, everything a PDF has to offer. And you can also switch the theme if you think that's a cool feature and explore the bibliography. But of course, that's not the most exciting part. You can explore interactive figures, take a look at the code that generated them, and even executed it in your web browser just by clicking this Binder Hub link on the upper left corner, which is again hosted on Neurolibre's own server to deliver content as fast as possible with all the data that was cached for that particular preprint. So if there is anything that you'd like to explore on the spot, change something and just change the color map, for example, you can do it and take a look at that T1 map in a different color map, for example. Okay, this is, yeah. But not all these living preprints have to be in multi-page format. This is an example from the reproducible research study group and also quantitative MRI study group in ISMRM. It was a 2020 challenge on T1 mapping using inversion recovery. And this work had 42 authors on it. And our submission workflow can propagate that information to all the reproducibility assets that was archived for this publication. As you can see on the Zenodo, we have all the authors with their ORCID IDs and everything. So everyone gets credit for each component that makes the living preprint actually alive. And this is the single page format. It has a more conventional style. You just keep scrolling down to read introduction, methods, results. But the only difference here is suddenly you see a dashboard embedded as a figure into article. And the dashboard is also hosted by Neurolibre. And it would take at least 50 different static panels trying to capture the information you can explore in this one figure. And just like the multi-page format, it has interactive figures, code, data, and you can execute it online and do whichever modification you want to do. You can scan this QR code. And also, yeah, another note on this dashboard, it was actually won an award by Plotly in a community challenge this year. And we are happy to host it on Neurolibre's own platform as a service, which is called Doku. and you can explore this dashboard live at this QR code. So how do we create these reproducible preprints? It all starts with a GitHub repository. First, we have Jupyter notebooks and Markdown files, and it's really important here that we highlight MIST and Jupyter Book projects that live under the roof of a community project called Executable Books. So you can use this MIST Markdown to create your narrative content. You can write equations. You can cite your references, add tables, admonitions, tabs, many cool web interface features that you wouldn't be able to incorporate into a PDF. Then you need to specify some runtime requirements, like what are the dependencies of your code. And this, you can achieve this by using configuration files recognized by Binder Hub, such as for Python, you can use requirements.txt, runtime.txt, or if you have a bit more specific requirements, you can write your own Docker file. There are many different ways to accommodate many different runtime specifications. Then, of course, we need to tell the preprint where the data lives. And for that, we have a JSON file. You put the URL, you give it that project a name, and then it will be informed about how to find that data. And then the last component is, of course, author information and bibliography. You just provide a simple Markdown file, and in its front matter, you list all the authors, affiliations, keywords, title, all kind of metadata. And then you also put paper.bib, a BibTeX formatted bibliography that is going to be used by notebooks to insert citations. So once you think that your repository is ready, you can visit robo.neurolibre.org, provide the GitHub URL and your email address. Then you will receive an email when the process is queued on our servers. And when it's completed, you're going to receive another email. In this case, the build has failed and the test server returned you a series of logs explaining what went wrong. After some debugging, if you can get it to run, it will return you a URL where your Jupyter book is accessible. This is, of course, just a playground. Once you're happy with the Jupyter book, you can submit it at neurolibre.org by logging in with your ORCID credentials. This opens a really simple submission form, as the repository captures most of the details needed to build all the PDFs, runtime, Docker image, all the reproducibility components. You put title, Git repository, name of the branch. If you want to build it from a different branch on your GitHub repository, you select the main subject for your paper. And then if you want to say a few words to the editors, it's also possible. And if your data has a DOI, you mention it here so that we don't archive the data for a second time. Next, we open a pre-review issue on GitHub to assign a technical screening to the preprint. I mean, here it's called review, but these are actually not reviews. These are technical screening, just to make sure that everything runs. Then we start the actual technical screening process, where RoboNeuro does the heavy lifting. You can see the first attempt to build the preprint fails, but the logs are available in the issue comment. After debugging, RoboNeuro returns the build book preview, also makes encouraging statements based on the submitted content. And this is, of course, given by ChatGPT running in the background. Then we build PDF from the notebooks and Markdown files. Then ask RoboNeuro to archive the repository data, build book, and the Docker image. And finally, publish the article where it receives its Neurolibre scoped DOI. After the publication, these preprints are indexed on Google Scholar. It registers all the citations given in the preprint, which is, I think, really important. And then similarly, other researchers can find and cite your preprint. And it also shows up on the ResearchGate, usually the next day, notifying your academic network that you published an Neurolibre preprint. And needless to say, the PDF is going to be available right in the notification. So I hope this was convincing why PDFs are just haunted mansions for code and data, which makes me think about the question, what remains of a paper if you take away the scientific prose? So I guess as nicely illustrated by Dolly, code, data, runtime, and figures, what remains after you take away the text. And if you've seen the Gemini which was released by Google 2 days ago, I don't have to convince you about the likelihood of AI coming up with some text for your figures. But I also want to give you a concrete example of how code and data can create a paper without writing the narrative content using GPT. And already I feel like GPT is kind of becoming an old technology. Just this last week, a lot of crazy things have happened, I guess. So this is a Japanese Sakura teamed graph visualization of 650 research articles about reproducible MRI research. They are clustered based on the word embeddings returned by the semantic scholar. And the red cluster here represents the articles from MRM, which nicely stands out from the rest of the articles, where the distance is kind of the measure of semantic differences between these nodes. And the red cluster also hits all reproducible research insight interviews published by MRM Highlights. So we have abstract, title, keywords, word embeddings, and also author's perspective on why the paper was reproducible, which was obtained, by the way, scraping the web using Python. So far we have zero text input. All these things are generated by code. And you can visit this QR code to see the Jupyter book that is generating these outputs. Then we use OpenAI to go through all these documents and make it learn about them, which is then capable of writing a review article about what makes which subtypes of MRI research reproducible. And on top of that, we can create a customized GPT that is context aware, not to hallucinate, and ask questions about these articles to gain insight that may not have been mentioned in the review article itself. So as subversive as it looks, what remains of an article when you remove the prose is code and data that created the narrative content, and the gap between the two is getting smaller and smaller. So whether we like it or not, the literature will evolve around these developments, and it will become more important to put our money where the value is, rather than chasing the ghosts of prestige for thousands of dollars in haunted PDFs. So that's all I wanted to say. These are the generous sponsors of the Neurolibre project. We are open for submissions, and our article processing charge is $0 right now. Thank you so much.
Thank you, Aga, for this excellent talk. There are a couple of questions in the Q&A. The first one is by Martin, but it might have been already answered during your talk, but I'm going to read it anyways. I've packaged up a software-defined radio low-field MRI system that was selected in 2017 by Johnson & Johnson Innovation Labs to 1-minute pitch them, and could utilize your Neurolibre for some stuff. How to utilize to create interactive PDFs, please?
Yeah, I kind of answered that question during the presentation, but if you visit the documentation, if you go to neurolibre.org, there's a link to the documentation page, and we try to put together all the instructions as to how you can create a Jupyter book. And then if you submit it, it will be published, which is really important for long-term maintenance of the resources.
Thank you. The next question, thank you for the presentation. Does Neurolibre focus on neuroscience research only, or is it also open for other types of research?
Yeah, it has neuro in the title, but we would like to interpret Neurolibre as free your mind from the limitations of PDFs. So any interactive article that is interesting to any kind of scientific community at this point, I think, can submit something to Neurolibre. So we don't actually have a really strict scope on that. I think we need more examples, and there is value in being inclusive to different research disciplines.
Yeah, thank you for clarifying. Also, do you think there will be a collaboration between Neurolibre and standard journals like Imaging Neuroscience in the future?
That's one of the visions actually of Neurolibre. We are trying to bring more community effort into Neurolibre, like the Jupyter community, so that journals can actually use Neurolibre if they'd like to. But it's also possible that after peer review, journals can link back to the Neurolibre version of an article. So both options are possible, and we are exploring these things. We try to reach out to certain journals, and it's not easy. It looks like there is a lot of effort involved in this, and yes, it's a bit more complicated than typesetting, going from Word documents to PDFs, but at least goes out to show that you can create some value if you are going to spend thousands of dollars. And I think that's an important message.
Yeah, thank you. I think with that, we can move on to the last speaker. Thank you, Aga, again.